會合辦一個系列講座。咁啊，今年就有4講嘅，咁今日咧係第一講，另外3講會喺8月。咁今日呢講咧，今個主題咧叫做外星人在哪裡咧？很遙遠，很遙遠。咁我負責講呢個講座就係 Dr. 希啦，咁佢係我哋嘅學術顧問啦，同埋一個係外行星嘅天文學家嚟嘅。咁我哋歡迎 Dr. 希啦。
Thank you. I'm thrilled to be here. And sometimes I do performances of comedy, and I like yelling "hot balls of gas" because where I come from, everybody knows that stars are just hot balls of gas. And anything having to do with astronomy, we talk a lot about stars. Stars are essential. Our star, the sun, is essential. So talk about stars a lot, and when you go out at nighttime and see the sky, that's what you see is a lot of stars. We're going to be talking about where is life, or where might ET be, where might extraterrestrials be, and so mostly be talking about where are they in the galaxy, and oftentimes, if you want to use a picture of our galaxy, well, we're inside our galaxy. We can't have a picture of our galaxy. It's not a problem that our telescopes aren't big enough. Well, actually, we do have pictures of our galaxy from the inside, and that's all. And you can see that at nighttime in a dark place. How many people in Hong Kong have seen the Milky Way at night? How many people here? You have to go someplace where you can see it, probably an outer island. The Milky Way is beautiful. And it lets you see that we're in sometimes they call it an island universe of a Milky Way shaped like a disc. And that's why when we're inside it, we see a band all across the sky around us. And you can see that different times of year. This actually is not the Milky Way galaxy. It's our big sister galaxy, the Andromeda galaxy, which is similar in size to the Milky Way, probably a little bigger, and it's probably going to crash into the Milky Way in 4 billion years. So we're hoping to find ET somewhere in the galaxy. This is what the Milky Way looks like from outside. The photographs emphasize it, so you don't quite see it with this detail with your eyes, but you really can see this band of light where there's just so many billions of stars that the light just blends into each other. And then, of course, a lot of it's covered by clouds. You actually can't see that far. This is probably Sagittarius. This is like the center of the galaxy. This is supposed to be our galaxy. Of course, it has to be a painting then. And when we go looking through ET, this is the kind of telescope array that we have. So the question, are there other civilizations out there? Not just is there other life like we might find on Mars or Europa, but are there actually creatures kind of like people? And not only are there intelligent people, but are they broadcasting? That's been a really popular question. The question is, are we alone? Science really changed when Nicholas Copernicus, he kind of got this idea that the Earth might not be unusual in the universe. And it turns out that he's quite a bit right. This principle has illustrated a lot of astronomy, that wherever you go, the laws of physics are the same, that the Earth is not the center of the universe. It's what Copernicus showed. Of course, he kind of thought maybe that the sun was in the center of everything, that the stars were just on an outside band and the planets were inside and the stars weren't really that big. But then with Kepler and other scientists, we realized that our sun is just an ordinary star. Actually a little bit brighter than ordinary. Most stars are smaller than the sun. But most of the stars we see are actually, okay, the sun is bigger than most stars, but most of the stars we see, we can only see the brightest stars. So most of those stars at night are bigger than our sun. We're actually missing the smaller stars. But if the Earth is not unique, can we really extend that to think that some other planet, someplace around another star, also has creatures like people or some other intelligent creature? And there's so many planets in the universe, you would have to guess that someplace that there probably is. Problem is that stars are so far away that any planet is so hard to study that it's only been since I started studying astronomy that we've even found any planets around other stars. And I remember to a time when a lot of astronomers seriously wondered that maybe planets were rare. Maybe all the stars appeared to be alone without planets. But that was just because the stars are so far away that it's extremely difficult to detect planets. And we still have not been able to find a planet as small as the Earth at a similar distance. We've barely found planets. We've found a few planets a little smaller than the Earth that are close to the star, or even some planets about the size of the moon around pulsars. But we wouldn't be able to have detected the Earth from around all but the closest nearby stars. So, originally, hundreds of years ago, when wondering about this Copernican principle, people just naturally thought, oh, well, the other planets likely had civilization. That there were probably people living on Mars and Venus. And when we started studying the rest of the solar system, the rest of the solar system looks pretty dead to any sort of, there's no animals anywhere elsewhere in the solar system, no trees. None of the worlds can have this. So perhaps that it caused people to think that maybe there's nowhere else with life. And so people wonder, since we don't see any real signs of life, any good signs of life, other than people making up strange stories. Can't quite believe that. So, scientists, when we're considering how many civilizations there are in the universe, we typically use the Drake equation, and we typically ask, what is N? What is the number of, we can call them technological civilizations, techno-civilizations for short. Or just, this is what we mean by ET. So we're looking for a civilization that is similarly broadcasting like we are. And so since, we've had radio broadcasts since around 1900, and I guess it was in the 1930s, that we've started having radio and the later TV broadcasts. Those are detectable in space, but it turns out that they are rather faint. We would only be able to detect those around the very nearest stars. Now, we have sent targeted signals just to say hello out there. We've sent signals out into space. And these signals, if some civilization intentionally allowed a bright signal like that, then we would be able to detect that from quite a bit further away. But we've only done that a few times, so you'd have to be extremely lucky to catch our broadcast like that. So I'm going to just jump ahead to the end of the talk so everybody knows what I'm aiming for. What would I like you all to remember when walk out of this talk? And there's kind of three big points. And the first point from astronomy is that the universe is just huge. The distance between stars is absolutely enormous. You can't say that enough again and again. Even though the speed of light is so fast that on Earth, hardly anything is delayed because of the speed of light. Oh, if you try talking on a phone that uses satellites, yeah, you'll have a tiny delay, or you can hear when the astronauts from the moon are talking. There's a delay. But stars, they're light years away, not fractions of light seconds. And so in this huge universe, there's a huge number of stars, a huge number of planets, and certainly if you go beyond our galaxy, there's billions and billions of galaxies that we can see with our telescope. So the number of planets, there's probably 10 to the 22, 1 with 22 zeros planets in the observable universe. So it's almost, with the Copernican principle, it's unimaginable that someplace there isn't somebody that's been broadcasting. And they could be broadcasting even now. And when I say now, I really mean with the light time. So of course, if they were 10,000 light years away inside our galaxy, when we received the signal, we wouldn't know if it still exists or not, because whether it exists, but in really right now, because the signal would be 10,000 light years old, or 10,000 years old. But when we say are there civilizations now, now we just mean wherever the signals would be coming from. So I've emphasized stars are extremely far away. The second point I'd like to emphasize, and maybe this is the most inspirational, the most significant point of all, that how many civilizations are broadcasting right now, or that we can detect right now, depends on the lifetime of civilizations. How long do civilizations survive? And that actually depends a lot on the choices we make. So I think one of the good things about seriously searching for ET, for techno-civilizations, is that it makes us think about what should we do for our civilization to survive. And it makes us realize that our civilization is actually very fragile. The environment is fragile. What we're doing is the way we're putting stress on the environment. The environment could collapse and we could have famine, or we might not be able to grow crops if we do the wrong things. And of course, we've also seen that the dinosaurs were killed by an asteroid. That's not very likely. That it only happens once every tens of millions of years to have that big of an asteroid, but a smaller one could hit us. Volcanoes could hit it. Volcanoes are actually more likely than asteroids. That's probably done a mass extinction. And these things we can prepare for. There's things we can do instead of just arguing about ideological sort of considerations. And then my third point, in coming down to this search, just about this search, is that we've only searched a small part of the space that we need to search. Jill Charter at the SETI Institute, that's the Search for Extraterrestrial Intelligence Institute, she likes to say, if you think of the whole space that we need to search as being equivalent to all the oceans in the earth, then we've only searched the equivalent of a small hot tub. So just a tiny area, and I don't know what she means by the space we need to search. I think that when you search a lot of the space, if you don't find something, you want to search further. And of course, some stars are searched very thoroughly, and other stars not very thoroughly at all, except with our current technology, we're really not able to do a really good, thorough search. So this Drake equation that organizes how we think about how many civilizations might might be broadcasting right now. And it's just an organizing principle, really. But it would be equal to the, normally I would say it's equal to the number of stars times the number of the fraction with planets. But Frank Drake was an astronomer, and astronomers love to think of the average rate of star formation per year. So that's the way the astronomers put it. But this basically is equivalent to the number of stars, the fraction of stars that have planets, the number of planets that potentially support life, or what we call Earth-like planets, Earths. And then of those, the fraction that support intelligent life. The fraction that support life, the fraction that develop intelligent life. And this actually goes through two stages. You can, when you just have life, most of the time, most of the Earth's history has been just single-cell life. It took a long time to develop multicellular life. And that seems to be one of the most difficult steps, is to go from 1 to 2 cells. And once you got 2 cells, you're quickly are millions of cells. And then how many intelligent species, how many of those have broadcasting civilizations? And then how many of those are broadcasting now? It's L. Let's see, so I've gone through all of these. So a calculation that was done by a couple of scientists at the University of Nottingham in the UK, they estimated, they went through this equation and tried to put values on these terms. And so the problem with this equation is we don't know what many of these things are. And we certainly don't know what the length of a civilization is. And so all they were able to do for like the length of the civilization is they said, well, we've had radios for 100 years. We'll just say they last 100 years. That's really pessimistic. That's assuming that we're on the brink of destruction, that we're not going to last into next year. And sometimes maybe it looks like that's not so far off. But that's very pessimistic. And if you think we're going to live 1,000 years, that we'll survive 1,000 years, then you can multiply their answer by 10. And personally, I think that whether we survive for thousands of years or millions of years, mostly depends on whether we survive the next 100. Because we've got, if we have a bunch of crazy political leaders, who knows what's going to happen. A little scary. But maybe searching for ET will give us some hope. And maybe if we get their signals, we'll be able to, they'll give us some pointers on how to survive. And so the other concept, if you remove L from the Drake equation, you can also get the archaeological number of civilizations. If you get too depressed that we can't find any civilizations, we can think, well, maybe the civilizations have come and gone, and in that case, you get a much bigger number. So when these researchers went through the equation, they guessed that maybe there would only be 36 civilizations in the galaxy. And at that rate, civilizations would be about 17,000 light years away from each other on average. That's a bit difficult to see. So Milky Way, 100,000 light years across. So 17, that's something like that far. So you'd have to be looking pretty far across the galaxy before you could find one broadcasting civilization right now. But you'd be looking past many civilizations that didn't survive. And you notice that even with their assumptions, their error bars are big. 36 plus 175 still could be over 200. That'd be a little bit better. Still would have to look far away. 36 minus 32, only 4 in the galaxy. That's really difficult. And so when we look through these terms, we actually know the number, we can see the number of stars. We know that pretty well. The fraction of stars that have planets, we've seen since I've been studying astronomy. When I first started, people really wondered, are there planets at all? We wondered that this might be even, only 1 in 1,000, 1 in 1,000,000 stars might have planets. But now we know that this fraction is pretty high. A lot of stars do have planets. Even the closest star to us has a little planet, Proxima Centauri. So we've made a lot of progress on this issue. And now we're actually working on trying to study the number of planets, how many of them have life. Now, how many have any kind of life? I'm very optimistic because life seemed to occur really fast on the Earth after it was formed. But life took a long time. There's a great, let's see, I got a picture coming up. The Science Museum has a really good explanation showing that most of Earth's history, 88% of the Earth's history, the Earth is 4.5 billion years old, so until about 500 million years ago, all the life was single-celled. And so my guess is that even if we find a planet that looks like Earth in size and has the same atmosphere, same distance, same temperature, most of them will probably just have single-celled life. Because it seems, from the Earth's experience, it seems to be hard. And that could be why that maybe Mars, if Mars has life, it's probably just single-celled. Jupiter's moon Europa. Jupiter's moon Europa, there's oceans under the ice. So that could hide whales and dolphins and squid and octopuses, and we wouldn't have any idea that they're there. But there's probably nothing like that because it's probably all single-celled. So that's going to cut the number of civilizations. And then it took a long time for life to develop into something that had civilization at all, had social civilizations. And it has to do with a lot of things. We joke about something being a dinosaur, but the dinosaurs were actually tremendously successful species that lasted for tens of millions of years. Human civilization hasn't done anything close to that. But we can hope maybe it will, especially if we develop space-based civilizations that don't rely on Earth's fragile environment. But right now, we can't depend on that. And maybe it was a good thing that the asteroid wiped out the dinosaurs, because maybe they just achieved a sort of equilibrium that they never were going to be able to develop civilizations. I can think of how octopuses are very smart, but octopuses are not very social. So octopuses, as smart as they are, will probably never develop. Even if the land animals are wiped out, they'll probably never evolve. So they never evolved into having intelligent species. So personality matters a lot. And then humans have been around for tens of thousands of years, but it's taken us, well, first it took us tens of thousands of years to develop civilization. But then, even then, it's taken us thousands of years to develop the technology to have radio broadcasts. But I would guess that this is fairly high, that if you have if you have civilizations like the Roman Empire and like even in North America, we have the ancient Anasazi that created these cities and the Maya and the Aztec. A lot of humans tend to form civilizations. So, and they tend to slowly improve technology. So this is probably close to one. But this is lifetime is something we don't know. And who knows, if we learn how to survive in space, either us or our robot descendants, robots are doing a lot better in space than people are right now. Robots have made it past Neptune and past Pluto. Humans, we just barely made it to the moon and we weren't able to stay there. So maybe a robot civilization would last. Right now our robots can't reproduce themselves, so that's a major impediment. But who knows, maybe in just a few decades we'll have 3D printers in space that are making new 3D printers. And that might be more survivable. And so maybe human civilization could last a few hundred years in space. If it lasts 100, why not expand throughout the solar system, last 1,000, last 1,000,000, last 1 billion? Well, maybe they don't last 1 billion because where is everyone? We don't see them, and that's, by this equation, I would say the one limitation that we have is that civilizations probably don't last so many billions of years that they've spread throughout the galaxy. That's kind of unlikely because we don't see them unless you believe those strange stories that I don't believe. So, we might have a few tens. It'd be nice to think, rather than just think of a few tens of civilization, you take away the lifetime limitations and you could go from a few tens of civilization in our galaxy to thousands, 10,000. Of course, the problem is, if they're not broadcasting, how would we see them? Now, maybe in the future, we'd be able to travel and see artifacts. Or maybe we'd find their spacecraft coming here. Saw an article recently where someone hypothesized maybe they've left little probes even hiding in our solar system, or put them on asteroids or on the moon. They're trying to say hello out there. They wouldn't do very well on the Earth. The Earth erosion would destroy them. So he thinks we should go look for those. I thought that's an interesting concept. Now, this person is a movie maker more than a scientist, and so maybe he's going to use that for some movie ideas. So our knowledge has grown quite a bit in my career. And I kind of think if astronomers were suspecting that maybe there weren't any planets, and now we know, well, obviously they are, I think we should have a little more faith that there probably really should be other civilizations, and I think we can learn a lot from them if we find them. So one of the most inspiring pictures from the space exploration, and we've learned a lot. This is called the Earthrise photo, taken in 1968 by Apollo astronaut William Anders. Poor William Anders, he didn't get to land on the moon. That didn't happen until the following year. This was kind of more of a test. But they described how spectacularly beautiful the Earth was coming up above the moon. And when it rose above the moon, they saw how the Earth could be so full of life. And the Earth, when you look at the Earth, you see the signs of the atmosphere. The clouds just dominate. You see there's ocean, you see there's land. You don't quite see there's life on this picture, but it's actually not all that hard. You can, if you're on Mars and had a small telescope, you'd probably see the patterns of life change with the seasons. Of course, you can also see patterns change with the seasons on Mars, and it turns out that's just patterns of dust. That's not patterns of life, and that tricked a lot of people. But the Earth looks quite a bit more alive than Mars, but certainly the moon kind of represents how dead to life most planets are. It's hard to imagine even single-celled life living on the moon. And the key thing is that the moon has no atmosphere, no water ocean, no ice that could cover liquid water. Mars has a thin atmosphere, a tenuous atmosphere. Europa, and actually quite a few of the outer satellites, even the dwarf planet Ceres, may have oceans underneath them. So that's a little bit possible. Which does make you wonder what would life look like if there is no land. And there's actually, if you think about the Earth is 1/4 land, 3/4 water. Is that an interesting coincidence? Is that another requirement for a planet to have civilizations? Because you can imagine, if the Earth was only 1% water, the land would be pretty dry and dead. Or the Earth could be 99% water with just a few islands, or completely covered with water. Actually, that's pretty likely. So that's an important thing that we're lucky about the Earth. There may be a few other requirements that not all planets work for intelligent life. Of course, if the Earth was a water world, could water creatures evolve to have civilizations? Now, if you had that, we wouldn't have any whales or dolphins, because whales and dolphins, they're smart, but they came from land. And actually, they're not very good with their flippers for hands either. And fish don't do very well. But octopuses, they do pretty well for moving things around. And so maybe there'd be a civilization of octopuses. That would kind of be a strange thing. I love the movie The Octopus, My Octopus Teacher, where they actually can protect themselves by picking up shells and surrounding themselves with shells. But they really ought to build themselves little houses to protect themselves from sharks. The problem with Earth octopuses is they're not very social. And they die right after giving birth. And so that's kind of no good for passing along knowledge and civilization. So you need something better than octopuses. So that kind of shows that personality is important. So, would we have expected to have found extraterrestrials if we have to go 17,000 light years to find them? And the answer is really no. The signal is just so faint that far away. And we've only searched a small number of nearby star systems. So we don't have to worry that the civilizations destroy themselves too fast or anything. We can just rest assured that we haven't found them yet. But it sure would be interesting to see the development of other civilizations. I'd love watching their nature shows and their science shows. Of course, that would probably change a lot of science when we'd be able to get their answers to some of our scientific questions. Then our science talks would be, well, we're doing this research, and what do the aliens think? It'd probably take us a while to decipher their language and to figure out exactly what they were saying. Though simple signals, we've actually figured out some pretty simple ways to make some pretty simple diagrams that probably wouldn't be very hard to decipher. Very hard. Probably would not be, shouldn't use the word decipher. Very hard to figure out, be very easy to figure out. So just to give an example of the numbers in astronomy, the Milky Way galaxy has 1 to 400 billion stars. And the majority of those stars, we used to say 100 billion stars, but actually we've realized, partly because of trying to address these questions of planets, we've realized that there's a lot of stars that are tiny, smaller than the sun. There's a lot more stars like that. And we're actually finding that a lot of them have Earth-sized planets, rocky planets. The only problem is they don't have giant planets. Actually, there's some big problems, though, with those rocky planets. In order to be warm enough to have life, to have liquid water oceans, they need to be a lot closer to their stars, and they in fact have to be so close that they're probably tidally locked, like the moon is tidally locked to the Earth. Do you know what tidally locked means?
Means just orbiting until that.
Orbiting until they don't give up. It means that one face, just like one face of the moon, is always facing the Earth. So, okay, when you look at the Earth from the moon, actually that Earthrise picture, when they say the Earth rose above the moon, the astronauts that were on the moon did not ever see the Earth rise. The moon is locked in the same face as the Earth. So when you see the Earth in one place, it would stay there forever. It moves up and down a little bit because the moon vibrates. But the only way you can have the Earth rise above the moon is if you're going around it. On the other hand, you wouldn't see the Earth wouldn't look the same because the Earth be rotating every 24 hours. So you'd see the Earth move and change. Be a lot more different than when we look at the moon, we just always see the same face. And it changes a little bit actually, but we never see the far side. So on the moon, you see the sun move every 29 days. That's a long day and night. And just slowly see the stars move through the year, just like on the Earth. So those planets around small stars, they're similarly locked with one face facing the star all the time. And can you imagine what would it be like if the Earth didn't rotate? You know how it gets hotter in the day? What? It gets hotter, right? Yeah, it gets hotter, and if a day was 50 hours long, oh, yeah, it would really get hot. But if you're just staying, people really wondered if you have the planet facing the star the whole time, that it would probably get so hot on the part of the planet facing the star that would probably just boil any ocean. But it turns out some studies said, well, the atmosphere should redistribute the heat, because there would be a very, very cold spot on the other side with a permanent night. It'd be very cold. So maybe those planets would have to have life in a ring around where the sun is just always kind of low down in the sky. And that might not work very well for intelligent life. So when you ask how many planets are there, we don't know if those stars, those small stars, are suitable. They're actually also highly variable. They have sudden explosions in brightness that could wipe out the atmosphere or kill anything. We're really lucky that our sun is a very calm star. And maybe not even stars the size of our sun are not quite as calm as our sun. So maybe you need a star that's calm like our sun. So for the distances to the nearest star, you know that it takes 8 minutes for light from the sun to reach the Earth. So the Earth's distance from the sun, about 150 million kilometers or 93 million miles, that works out to be 8 light minutes. The closest star is 4.3 light years. That's 272,000 times as far away as the sun. So that's why it would take a long time for any sort of spacecraft, even going at the speed of light, to make it to the nearest star. the only way people could travel to other stars would be you'd have to have multiple generations, a spacecraft of multiple generations, and that would be pretty hard to, then you'd probably want to have 1,000 people on the spacecraft. And we're far away from doing that. So we have to deal, when we're trying to study life on other planets far away. This is going to make it very hard to study if we're able to find a planet with complex life. But I sure would be interested in finding what the alternate evolution looks like. So, let's see if, oh yeah, I wanted to, about single-celled life. This is a really great diagram at the Space Museum. At the Science Museum near here. Go and see this where they put the Earth's history as a single year. And so most of the space here, I wish I had a picture closer up. This is where we are here in December. And you notice they expand December and November because this space is too small. So among the Earth, so the Earth has the life is been here for 4.5 billion years, and it's only up here at 540 million years the single-celled life appears. So go and see that. Okay, here's all the figures. So my guess is that some of these planets, we're seeing now some planets that are kind of in the habitable zone. And that they're Earth size. They're not too big, not too small. But my guess is that even the best planets, most of them are going to just have single-celled life. Now, how can we search for other civilizations? There actually is a project, the Search for Extraterrestrial Intelligence. This is in California. It's called the Allen Array because Microsoft co-founder Paul Allen funded it. Let's see, in this picture they're kind of looking at more towards the horizon, but usually they point more upwards and they can look for signals, for radio signals. We think radio signals are the best. It's amazing that we can use radio to communicate with our spacecraft even past Pluto. Even a very small transmitter. Radio is very effective. It would be pretty impossible to try to see a light signal from the Earth. But radio is very distinguishable at long distances, even interstellar distances. A little diversion. Are ETs hiding their visits on Earth? You know, the UFO question. And actually, the US is doing a new study of, they don't want to call it UFOs anymore, they want to call it unidentified aerial phenomena. Because we don't even know that they're objects. And there's no reason to assume that an unexplained object is extraterrestrial. There's just a lot easier things to imagine. Strange things in physics, strange things that the eyes can do or that detectors can do. There's probably something in the atmosphere that forms shapes. We know that there's like ball lightning, and ball lightning is a little bit hard to understand. We don't quite know what it does, but apparently we've actually been able to reproduce a little bit of ball lightning in the laboratory with big sparks. Ball lightning is supposedly the people have seen balls of something just floating from thunderstorms. And that could be real. It's a little hard to believe something like that would exist, but not too much of a surprise. There's always been myths and mysteries, unidentified stories. There's always been ghosts and leprechauns, sea monsters, Bigfoot, Sasquatch. Humans love mysteries, you know, the Twilight Zone And you have to wonder, why do the UFOs, why do they visit Americans more than anyone else? Probably because Americans have crazy TV and go out in dark nights. I don't know, maybe it's because Americans have guns, I don't know. Kind of scary to be around. It's hard for me to imagine that some civilization that could manage to make it to the Earth would be able to mostly hide from us, but would occasionally make mistakes and not perfectly hide from us. I think they'd either hide from us effectively or not at all. They could say hello out there. They could give us some good advice. We'd like to listen. So I kind of think that we have not detected alien civilizations. Maybe we're, I should also mention that maybe we're early in the universe. You know, the universe is only 13 billion years old. I didn't create a slide for this, but it's kind of an interesting concept. The Earth at 4.5 billion years, that's more than a third of the age of the universe. So things in the universe in some ways have kind of started. On the other hand, though, even though the universe is going to last for tens and hundreds of billions of years more, the Milky Way is already using up the supply of making new stars. So there's not going to be as many new planets being formed. And so maybe we're not that early. Maybe we're just at the peak, the universe's peak of creating life. But I kind of think maybe we're early. And maybe in a few billion years, the galaxy will be covered with civilizations. If they can last long enough, if they can make it through all their dangers. So I don't think there's E.T. It's great for movies. Okay, so the question is, how long do civilizations survive? Well, we survive long enough to have self-sustaining space stations. Here's a picture of the International Space Station. China's just putting up another space station. And when I was first interested in science, these were kind of like science fiction. But these don't really count much for just starting to learn how to do it. These space stations are super dependent on the Earth. It's only been in the last month that they could wash their own clothes. They have to have everything, even their clothes, shipped up from the Earth. I think that they can clean their air, but they haven't gone very far on growing plants or reusing materials. So it would really be nice if there's self-sustaining space stations that can survive that can actually use like materials from the asteroids, then that could be a lifeboat. That even if civilization down here on the Earth destroys itself, that out in space we could survive. But this space station won't even, I don't think it will stay in orbit forever. There actually is a little bit of atmosphere up here that's slowly bringing it down. But they just want to be close to the Earth to not have to deliver supplies so far to study the Earth. I also like this picture this is the Earth's atmosphere. Look how small, how thin, how fragile it is. One of the biggest lessons in the space program. And finding a planet with this atmosphere. And we don't even know if, the Earth's atmosphere wasn't a wonderful oxygen atmosphere for much of our history. We can think, next time you get upset at blue-green algae for stinking and making a mess, making your life uncomfortable, thank them for a moment for creating our oxygen. The algae probably created more oxygen than the trees and probably the algae in the oceans. So species lifetimes, we got to protect ourselves against natural disasters. This is a painting of asteroid coming, and you know, these dinosaurs are all dead meat. Big 6-kilometer asteroid, 65 million years ago, hitting the boundary between Mexico and the Caribbean Sea, Yucatan Peninsula. That did the end of the dinosaurs. They should have painted a few little mammals running around in the bush here. We're descended from those mammals. So there should be some mammals here that are hiding. The mammals had bodies that could survive better. Now, if this was us here, well, I guess there'd be insects down there. Actually, I'm sure there are insects back then, too. Insects seem pretty survivable. Now, one thing important about asteroids is that with our space program, that humans have the capability to detect an asteroid before it hits the Earth and to move it out of the way. So that's when we want to improve our lifetime and our survivability, developing an asteroid defense program would help, just help a little bit actually. It's one of the smaller dangers. Even more likely are supervolcanoes. I think that there's been more extinctions in the Earth history from supervolcanoes than the one from the asteroid. Volcanoes happen more often. We've just had a pandemic that we've learned we need to prepare for pandemics. And actually pandemics are one possible thing that, usually pandemics are pretty safe. For species, they just kill a fraction percent of people, or the Black Death in Europe was pretty horrible. I think it killed, was it 2/3 of the people, or 1/3 or 2/3, I forget exactly. But a really horrible pandemic. It's potentially possible that a pandemic could wipe us out. Maybe a pandemic in conjunction with one of these other things. So we should prepare for pandemics. We should prepare for volcanoes, and actually the worst thing volcanoes could cause is a volcanic winter. And actually volcanic eruptions actually occur like every century or so. You know, there were years without summer in the 1800s. And so it's a good idea I come from a culture that in Utah people like to store food, and that's probably a good idea to have a little bit of food on hand just in case there's a huge volcano. Yellowstone in the US, or some places in California, are potential supervolcano hotspots. Certainly it would surprise no one if places in Indonesia or the Philippines went into a supervolcano. But perhaps our biggest dangers are what we're doing to ourselves with climate change, or what we're risking with nuclear war. A nuclear war could cause a nuclear winter. This is a painting of that the light from the sun could get blotted out. So this is a little worse than the volcanic winter. In volcanic winter, at least the buildings would still stand. And then if we don't take care of our climate, global warming is going to get a lot worse. We're going to really have to think of how to deal with this. And I'm sure curious, how did the aliens solve it? How did they solve global warming? How did they get along and not fight with each other with nuclear weapons? And how did they just take things like volcanoes seriously? How did you think to survive long enough to, my guess is that if we see a signal that they will have survived for many thousands of years. For one thing, it would really be a lot better if an alien civilization had a much stronger signal than anything we're putting out from the Earth. It's kind of hard to detect that. And I would be really grateful if some aliens would say, hey, hello out there, and by the way, this is how you solve your problems. This was just last month, 54 degrees in Death Valley. Just this past week, huge die-offs of animals off of North America, off of the coast of Maine and off the coast of British Columbia, Canada, Washington State. We wonder, are coral reefs going to survive? Many species are endangered. So it would be better if we could really dedicate a lot of our resources to solving these problems instead of just having parties and having disagreements. So maybe finding ET would really persuade people. Just even looking makes people think about this. And I would think that if we looked for ET for answers, we probably would end up finding out, oh, we already knew the answers. People were already trying to tell us, but no one would listen, kind of like the pandemic. That some people wrote books. And actually the US President, George W. Bush and Barack Obama, they were kind of preparing for pandemics, but the president, when the pandemic happened, he had just dismissed a lot of those people. So sometimes we like ignoring good advice. And it would probably be persuasive if we had an alternative history of success and survival. And maybe those aliens would even be able to give us the stories of a few other civilizations in the galaxy that didn't make it. That would be interesting if we could listen to other civilizations. They could probably tell us about what civilizations they found. So if we found one, we could maybe find many. What would ET look like? I think if they're on land, that 2 legs, 2 arms, 5 fingers on each hand. That just works. They may only have 4 fingers or 6, but, or maybe they'll have eyes in the back of their head. I think they certainly would have different hair patterns. That kind of changes between different peoples. So they probably would have some different physical features. Maybe they wouldn't have toes. I don't know. Toes don't seem to be quite as useful. Maybe their personalities might be different, though. Often it appears that chimpanzees are more tend to violence than humans even. And that's probably not good. We're kind of on the borderline of destroying each other. We spend so much effort fighting and put so much of our resources in the militaries. But if we're like bonobos are the real make love, not war. They participate in other activity rather than fight. Keeps them calmed down. So there aren't such serious conflicts between bonobos. And so the personality of other species might be better. I mentioned, what about water worlds with no land? Having many tentacles, that might work very well. So maybe, of course, water world might have such thick clouds, maybe they wouldn't be looking up into the sky very often. Maybe they wouldn't know much about astronomy. It'd probably be a lot harder for them to broadcast. You can't broadcast radio waves through the ocean. So it'd be harder for them to use radio waves. So water worlds just may not be quite as good. Of course, just because earth octopuses are not very social, octopuses, there might be some more social octopuses in other worlds. So let's go towards the ending. I want to emphasize how even the search for ET could bring the world together. So back to the 3 points as the conclusion. I always want to emphasize to people when I'm talking about astronomy, it's why we have the word astronomical, that the numbers are huge, the number of stars, the number of planets, and the distances are huge. If you think distances in the solar system are big, and they are, the Earth is very far from the sun. the distances between stars are just so much more enormous. Interestingly, though, beyond that, distances to the next galaxy are not really that much further. You know, the Milky Way galaxy is 100,000 light years across. The Andromeda galaxy is a little over 2 million light years away. So just a little over 20 times the diameter of the Milky Way. So stars are so far away, the nearby civilizations are going to be very hard to detect. Planets are very small compared to stars. And so even finding planets has been something that, I remember a time when people despaired of thinking, oh, there aren't planets because we should see them by now and we don't. And that was actually kind of a problem with the instruments. There were in the 90s, early 90s, people thought there really might not be very many planets around other stars. Emphasize how many civilizations are broadcasting now, depending, I'll call that humanity's biggest unknown question. How long do civilizations survive? And that depends a lot on what we decide. And that would be the biggest takeaway from this talk that I hope you have. But on this subject, the takeaway is we've only searched a small part. I think civilization, now that we've found there's a lot of planets, the idea of there being other civilizations begins to look a little bit more likely. That I think we could really start looking hard and really trying to see. And that's a whole nother talk about how do you separate out intelligence signals from natural signals. And that actually Hollywood does a little better job of, you know, if you see a signal with prime numbers, for example, 3, 5, 7, 11, that's not a very natural sequence. It's very easy for civilizations to say hello out there like that, but maybe they're not saying hello out there. You know, most of our signals are not saying hello, and it'd be a little hard to make sense of our TV and radio broadcasts. And if you see the movie Contact, it'd also be kind of confusing that some of the first radio broadcasts, first TV actually showed Adolf Hitler and the Nazis. That's kind of an embarrassing introduction to Earth life. So if we focus on preparing for a long and happy future, for a long lifetime, let's live long and prosper, be happy, let's protect the earth, seek peace, and let's talk a lot about solving the world's problems. And that can all start with everyone get vaccinated. Thank you.
好多謝多推佢哋講咗啦咁樣，但係各位觀眾冇問題想問下多推咧？
That is, what if the civilization has developed some signals that are even faster than light?
Well, if the signal is faster than light, that still wouldn't make a big difference in how many signals how many civilizations that we could see.
Why?
Well, I guess, yeah, I guess if you have signals going at different speeds, you could start collecting a few more civilizations. But the problem is, how would we detect something going faster than the speed of light? We don't know of anything. We can't detect anything going faster than the speed of light. It would have to be something that would also trigger our radio telescopes without us being aware that we were looking for it.
Then I think that they may be faster than light, but there's some kinds of signals that some kind of signal light but faster than light.
Well, going faster than light is impossible. It's the nature of the universe. And when you study physics, you realize that information cannot travel faster than the speed of light. So if you start talking about faster than the speed of light, then you're talking a little bit of fantasy. But you can still say, well, what if that's wrong? But if you say, what if that's wrong, then I guess you could come up with anything.
Excuse me, I want to ask, there are many types of exoplanets, right? Can you explain some of the types of exoplanets?
Yeah, many of the main kinds of planets you can see in our own solar system. There's the giant planets, Jupiter, Saturn, Uranus, and Neptune. These are gas giants. Basically what you have when you form a planet, okay, you have the rocky planets like the Earth and Mercury, Venus, Mars. As the planet gets bigger, once it gets big enough, it can start to collect hydrogen and helium. And the Earth is the biggest rocky planet in the solar system, but our gravity is not strong enough to hold on to hydrogen and helium. And Uranus is the lightest giant planet. And so its core was able to get big enough that it could actually collect hydrogen and helium gas. And once you have that mass, and when you're forming planets, you're in the disk of dust and gas. What happens is called runaway growth. Then all of a sudden the hydrogen and helium will collect on that planet, and it just starts growing bigger and bigger and bigger. And that's why the 4 giant planets are so much bigger. The kind of planet, extrasolar planet, that we don't have here on the Earth are the super-Earths, or the sub-Neptunes, is what they call them. They should call them the sub-Uranuses, because Uranus is smaller, but no one wants to say Uranus, so they call them the sub-Neptune. And so that's a planet that's more on the boundary. And we're not exactly sure where the boundary is, but it appears that it's about 1.6 Earth masses. We actually might be seeing a signal that once rocky planets get to 1.6 Earth masses, then they can collect more hydrogen and get bigger. The other kind of extrasolar planet that we don't see are hot Jupiters or hot Earths. It turns out that it's very common for planets to be closer than Mercury to their star. So Mercury, as hot as it is not really that hot. It's not that close to the sun. There's a lot of planets that are just being boiled off. And of course, those planets, it's hard for a sub-Neptune, sub-Uranus planet to hold on to its gas that close to the sun. So we don't see any hot planets in the solar system. And then it's also possible that there are very cold planets far beyond the orbit of Neptune. A planet that's bigger than Pluto. And such a planet might even exist in our own solar system. A planet that's as massive as the Earth, or a few times as massive. Planet 9. So that's another kind. But I think the Earth kind of makes the best example of a planet for life. And the next best examples would either be like Europa or Titan or Ceres.
其實有冇其他問題想問咧 ？Any question to ask over here？ 如果冇問題咧，咁今個OK 有人想問。
Hi,
Hi, good afternoon, Dr. Taylor. Just a quick question here about, do you believe that humankind is really the pure evolution from single cell, or is it, from the religion perspective, is sort of the intelligence planted from higher civilization or Akkad, the god, right? So I think that's the first question. And the second question is, there's a lot of those cutting edge scientists are getting into studying the convergence between the science and the religions, and I just like to have the point of view, your point of view. Thank you.
Well, science has to just study science, and so of course, science is very well documented the steps from evolution. There's really no missing link. There's tiny missing links, but we see the pattern of single cells going to multiple cells and becoming more complex. And life, I should mention, life doesn't always become more complex, doesn't always become more intelligent. But the hominids, like with the Neanderthals and Denisovans, the other extinct species that were similar to humans, that shows an evolution. The one thing I think that's important for the people, for the lifetime for humans to survive, I think that we need to unite on the idea of working together to protect our environment and be safe, because I admit I come from a religious background, and some of the people in my background, they think like, oh, well, God wouldn't allow us to destroy ourselves. And I think that's a dangerous concept, and I would question that God has not seemed to step in and solve our problems in any case. And so I would question that that's even a religiously very smart way to think. But that affects a lot of people in the US when people are focusing on their particular brand of religion, which is too bad, because a lot of religions, there's a lot of good. When I began to question my own religion, I thought, well, just focus on the good things of caring about people, and just try to live a moral life in a way that doesn't depend on one ideology. And certainly trying to protect the environment and trying to have humans survive. I should mention also that we know that there's been small civilizations on islands in the Pacific Ocean, among the Polynesians, that some of those did not survive. Some of those died out. We know of civilizations, we know the Norwegians, the Norse in Greenland, they didn't survive. They died in their beds. So we know that on smaller scale, civilizations cannot die, and God didn't save any of those people. So I've sometimes had to argue against people from where I come from in the U.S. that we really need to be concerned on this. So a particular example is a lot of religious people that don't believe in global warming. And God never said, don't worry about global warming, but people want to use their religion as a license to do other things. And I think that, well, in the U.S. we think that religion and politics need to have a separation. Well, that's the original founding idea. And when that breaks down, when people start arguing over religion, when we should be arguing over science, we should be discussing protecting the earth.
Any question? Có một cái問題không ạ?
Oh, and I'll mention, get vaccinated. Let's not argue over that. Some people think, God, you don't need to get vaccinated. I hope everybody's getting vaccinated. Certainly, I kind of worry about Hong Kong, not as many people are persuaded because we have it so safe here with such low COVID. And that's one thing that I felt so safe in Hong Kong that I had a dream once a year ago that I just going along, and all of a sudden I realized I'm not wearing a mask and I'm in the US. I'm going to get sick. I'm going to get COVID. And as soon as I woke up, saw my apartment, saw my wife with it, safe. Well, now I'm vaccinated, and so I'm a lot safer. That's the only way we're going to get out of this pandemic is vaccination.
Hi, Professor Taylor. Thanks a lot for the speech. Have you heard of a theory called dark forest theory from a famous science fiction three-body? And it means that a civilization should never publish its own location, given that it will be haunted by a more senior civilization. And do you agree with this theory? And do you think it could be the reason that we haven't detected any other civilizations because they are afraid of this possible danger? Thanks a lot.
Well, that is an interesting idea. Maybe other civilizations are covering up. I don't think they would need to cover up their signals for us not to be able to find them, because it's very hard to detect other civilizations. Well, they wouldn't need to for us to have found them now. Of course, if we really expand our search, or then we'd be able to pick up just their regular TV. From that standpoint, I think it's pretty hard to hide in space against a really advanced civilization. Our star is just shining brightly out there. If they're like us, they're going to be looking for planets and they're going to be looking for life. I think that the thing that is most interesting about other life, either to us or to them, would be the scientific study. And so I don't think that they would want to exploit us. I think that there would be plenty of worlds. I mean, they could go to a world, one of these worlds that just has single-celled life, and they could colonize that. I think that we would just be so interesting. It's kind of like today. Ancient tribes are a lot more interesting. And so we try to protect them. Of course, today it's a little bit hard to keep people from traveling to those ancient tribes. So I hope that any civilization that manages to last long enough to come here or to detect our signals, I hope that they're very benevolent. I hope they're good. They've learned to solve their problems, and we could learn from them.
仲有冇其他問題想問啊？我聽你傾下。如果冇嘅時候，時間都差唔多啦。咁我哋下一節咧會係8月8號嘅，多謝聽日先。多謝。